Hello 8th graders. In this video we're going to be taking a look at IXL assignment N4, which is about finding the distance between 2 points. But they really should have put this down in cluster R with Pythagorean Theorem, because the way you find the distance between 2 points on a graph is to use the Pythagorean Theorem. It's to create your own right triangle. If I'm on a graph, I can count if movement is exactly sideways, like I'm going to show you with this red line right now. If something goes straight sideways, one arrow, one line, if something goes straight sideways, I could use the graph to count exactly how long it is. This goes from -8 all the way over towards +1 by the end of this red line here. You see it lines up with +1. So I could know that it's 9 units sideways. I also, on a graph, can count if a line goes straight up and down, like I'll put here in blue. If a line were to go straight up and down, I could count how long it is. Like this one here, I see it's just 3 units long because it goes exactly 1, 2, 3 grid boxes. So I could call that 3 units long. However, if we have a diagonal line, for example, something that connects this green dot at -8 and -10, with this dot up there at 1 and 2, we can't really use the graph to count how many spaces long that is. However, there's something really important that we can do. If we had a right triangle here, if we created a right triangle, and I'll show you that right now, by drawing one line straight sideways that goes towards the other dot, and then one line that goes straight down, this forms a 90-degree angle. It's got one vertical leg, one straight sideways leg, and I'm going to draw in red now a line that connects those two. And that's really the one we want to know. I'm going to put a question mark there. How long is that side? How long is the distance from this -8, -10 dot up to the +1, +2 dot? And now if you see this right triangle, and if I can count sideways distances or vertical distances on graphs, I could figure out how long the two legs are now. I know this sideways horizontal leg on the bottom goes from -8 all the way over to +1. So I could count all 9 spaces here, or I might know to get from -8 to 0, I go by 8, and then this goes one more spot, so that's 9 units long. So I'm going to go ahead and call at the bottom here, that leg is really 9 units long. I know that just by kind of picturing or drawing this triangle in there. It goes from -8 on x to +1, 9 units long. And then the y value goes from -10, it's 10 units below the axis or the origin here, all the way to 2 units above the origin. So if I jump by 10 units and 2 more units, that gives me a total of 12 units tall here. It goes up by 10 units just to get to the x-axis, 2 more units to get up to +2. That's 12 units. And now, hopefully you can see that right triangle. We know it's 9 and 12 for the 2 legs. And some of you might be screaming now, Mr. Doherty, all we need is that Pythagorean Theorem. And you'd be right. This is why I think distance of a diagonal line on a graph is really just a Pythagorean Theorem problem. You create your own right triangle, you measure the size of the 2 legs, and then you use that formula to find the real distance we cared about, this red line that connects the 2 different points that are diagonal from each other on the graph. So I'll go ahead back to that formula now, a squared plus b squared, and I'm going to plug in, using those 2 legs there, 9 squared plus 12 squared. You could be doing this out on your paper, your whiteboard. You've hopefully familiar with this from R1 through R4 already anyways. And when I do 9 squared, I get 81. When I do 12 squared, I get 144. So we see here this really just becomes 81 plus 144 equal to c squared, and we've got that in red now. I add those 2 sides together, 81 and 144, and that gets me to 225, which is equal to c squared. Some of you might have seen this 3, 4, 5 triangle, or in this case 9, 12, 15 triangle. They multiplied everything by 3 here. I take the square root at the end, we'll put that in purple. And when I take that square root from both sides, that tells me that c must be equal to 15. 15 times 15 is what makes that 225. And there I'm just double checking. Yeah, 15 units seems pretty reasonable for the longest side of this triangle we created on our own, if it's 12 tall and 9 wide. So we are going to do one more problem here where they show us the graph where they give us 2 points on it, but it is going to be very much the same procedure the whole time. So I would encourage you right now to actually try and do this one on your own before you watch me working this problem out here. As you're coming back from trying to do this on your own, hopefully your first step was to try to create your own right triangle. It can be a little difficult. You could draw on your screen with one of the drawing tools. You could write this out on a piece of paper. It is annoying on a computer. I follow you there. But I would go ahead and make a sideways leg until I get far enough over. I would make a straight up and down leg from the other dot. And then I'm going to connect those 2 legs right here. And that's really going to be the thing I care about finding in red. How long is this diagonal line that connects this first point, -9 and -6, with that other point on the graph, -3 and +2? Now, I know the x value starts at -9 here. I see that on the coordinates right between the 8 and the 10. It finishes at -3 here. To get from -9 to -3, I know that must be 6 units. It gained 6. It went right by 6. So I'm going to go ahead and label that one as 6 units on the bottom. And you note for the other one, it goes from -6, right here down to -6, all the way up to +2 at the end. So to go by 6 and 2 more units, that's a total of 8 units. So we would say this triangle is 8 units tall, 6 units wide, and that 8 and 6 is now my key to find the hypotenuse, the red line that connects those two. So plugging into the formula, I'm going to do 6 squared plus 8 squared, and that needs to equal the red side there, c squared. Some of you should be familiar with this by now. We could do this out. 6 squared is 36, 8 squared is 64, but when we add them together, we're just going to end up with 100. You've seen this triangle before, the 6, 8, 10 triangle. It's just a 3, 4, 5 triangle doubled. So when I square root at the end here, that tells me that c must have been 10. Because the square root of 100 is 10. And that 10 for C seems very reasonable to me when I see that the other two are 6 and 8, and it looks like that 6, 8, 10 triangle I've seen popping up. We're going to skip ahead to the challenge zone to see if there are other problems here that are difficult enough that merit going through, or if we're just going to kind of leave you on your own to say it's pretty much the same type of stuff the rest of the way. Yep, this is what I thought they might be doing. So eventually, once you get past 70, like you can see here, they're going to take the triangle away from you. They're going to take the graph away from you. But I know this, if I measure the x change, that's one leg, and if I measure the y change, that's the other leg. So here in red, I'm going to put a red underline under the, oh sorry, I guess it's orange. The x value went from 2 to 9. So I know from my triangle, how far sideways did it move? It must have moved sideways by 7 units. The x value went from 2 to 9. This one's a little weird. The y value, which I'm going to put into red, the up and down one, that goes from 2 to 9 as well. So if it went from 2 up to 9, it climbed up by 7 units. And that should be a perfect right angle. I didn't do my best job there. Sorry. And then we know what's connecting them is going to be our hypotenuse. I'm going to put that into, I guess, green, since we already used the red color. Purple, I guess. That's what we really want to know here. Those are the 2 points. From 2 and 2 to 9 and 9, this is what it would look like on a graph. I'm going to go ahead and do 7a squared plus b squared equals c squared here. And we know that the 2 legs are each 7. They're 7 and 7. So it's really going to be 7 squared plus 7 squared equals c squared. Or you all know 7 squared is 49. So this is 49 plus 49, which really just becomes 98 equals c squared. Sorry to do a couple steps at once there. The last step we would do is we would take the square root here. So I'm going to go ahead and show a square root. Oh, let's pick a different color. Let's put that into orange. And that square root is going to help us find the final answer. I type in the square root of 98, and I find the square root of 98 is 9.899. Fun one there. 9.899. And that's equal to our C. Now, I go look, I need to round to the nearest tenth according to IXL here, so I look at the first digit after the decimal, that is in the tenths place. That's the 8 right there. I see a 9 comes after it, so 89 is closer to 90 than it is to 80, so instead of 9.8, I'm going to round my answer to 9.9, because 89 is closer to the 90 than it is to the 80. I'm not going to continue to go here. As you see, the challenge for N4 after you start making your own right triangles on the graph is they'll take it away and just measure the exchange. Oh, it moves sideways by 5, it moves down by 9, so this one would be a 5 by 9 triangle, and you could find the hypotenuse. If you do have questions, this can be tough at first for sure. My email address is ddoherty3@bostonpublicschools.org, and I'm always happy to chat math if you send me a GChat or an email there. Other than that, keep up the great work, and thank you for working to one of the more difficult assignments related to our Pythagorean theorem.